Hello guys, welcome to FM Tuition Academy. Okay, it doesn't matter where you're watching me from. You could be a grade 10, a grade 11, a grade 12, or somebody who is going to write GCE this year, but you want to learn, you want to improve, or you're writing GCE next year. Now, this here at FM Tuition Academy, we're exposing you to materials that will help you to pass the exam. So like today, we're dealing on strategies on how you can answer practical questions in chemistry. Okay, so if you're a grade 10, a grade 11, a grade 12, or somebody planning to do GCE, comment your phone number right now so that we are able to assist you to pass this year's exam or next year's exam. Now, comment your phone number right now. So, this is a practical question in chemistry. This is practical chemistry. Okay, practical chemistry. Okay, practical chemistry. It's titration in nature. So, these are the steps. This is step 1, step 2, step 3, and so on. These are different steps. Step A, step B, C, or D. They can write either 1, 2, and so on. Now, there are certain things that you need to know. For example, titrate Q with P of hydrochloric acid. So, whenever you're dealing with titration, it is always a base and an acid. A base and an acid. That's how we solve, base and an acid. So if they're saying titrate Q with P of hydrochloric acid, meaning if P is hydrochloric acid, meaning automatically Q is a base. Okay? If Q is a base, meaning P is an acid. It doesn't matter. So like for example, just from the statement, step 1, titrate Q with P of hydrochloric acid. Since P is hydrochloric acid, meaning Q is a base. Another way on how you can even know this is also by looking at this box. This is called the titration box. You look at the letter, the one that I've used in the titration box. For example, I've jumped all these steps. I'm looking at this. This is final reading, initial reading. But if you look here, they're saying volume of P used. So the letter that you're going to use here is always the acid. So this box is for the acid. And then what letter is it? P. Okay? Even if they didn't tell you in the question here, by looking at this box, you are able to tell if the letter here was Q, it means Q was the acid. Is that clear? Since it's P, volume of P, because this table is for the acid. Okay. I was just trying to open your mind. Now, solution Q is 1.00 mole per decimeter cubed of sodium chloride. So it means Q is a base. Have you seen? Q is a base. Q is hydrochloric acid. So it's a base. So Q is a base. As I said here, Q is a base, P is the acid. Put P in the burette. Put P in the burette and pipette 25 or 20 cubic centimeters of Q in a conical flask. So it means you are mixing P and Q. You are mixing the acid and the base. And then, at what volume do you see changes? Okay, when you are titrating. I think you have seen the titration experiment where you see their color changes. So when you are titrating, you put the acid in the burette and then the base in the conical flask. And then when they change color, you take the recordings, okay? So you always start from 0. It doesn't matter, you can start from 0 or you can start from any number. But like I said, for example, if the titration you do, maybe you don't want to do this experiment, you're in a hurry. The exam is very fast. I can teach you the fast way on how you can even use your own numbers to write this table. So for example, we're trying to use the titration between 18 to... let's say 18 to 21. You want your titration to range from 18 to 21. So here why is initial volume here? You can put 0. Even here 0, even here 0. Okay? So there are many titration, this titration box, how many? Titration number 1, titration number 2, number 3, number 4, it can be number 5, number 6, number 7, it can go as many as you want. So if it's 18, so meaning here I'll put 18.1. If I want, it's a choice. Since I want the titration to be between 18 and 21, here I can put 18.5. Here I can put 19 if I want. It's supposed to range in here. Here I can put 20. And then here everywhere I put 0. These can be my titrations I want to use. Since I want it to range between 18 to 21. It can be, I can start from 19.1, 19.2, 20, 21. It doesn't matter. I choose which numbers to put here. But they should range between 18 and 21. Okay? They should range between 18 and 21. So when we are saying volume of P used, it is 18.1 minus 0. So here it will be 18.1. 18.1 minus 0 again here. It will be 18.5. 19 minus 0, it is 19. 20 minus 0, it is 20. This is how you fill this table. And then from this titration, you pick your best titration. Say best titration, meaning which one seems to be the best. Okay? Which one seems to be the best? You can pick. So the one that is appearing as though it's appearing most. Have you seen 18? It looks as if it's appearing most than all of them. It's 19. Or if you want, you can add this one plus this one plus this one plus this one. And then you add them, you take the average. There are how many? 1, 2, 3, 4. You divide by 4. The one that is nearer to that number is the one you pick from him. Okay? Now, I was just trying to open your mind. Now, if you want, okay, this is the simplest way. That's the reason why I want to go to this. I've started with 0. Okay? I've put 0, 0, 0. If you want, you can put 2 here, and then you put a different number here. You can put 3, a different number here. 4, a different number here. But I've used 0 because it's faster. If you start from 0, it is faster. Okay? So you don't have enough time, because in the exam, you won't have enough time in your exam. Okay? If you want, you can use 2 here. I can put 2 here, and then I put a different number here. I can put 4, a different number here. But the numbers should range from within these 2. So when I subtract those 2 numbers, the answers should range between these. But let's just use 0, because 0 is faster. So all the time, try to use 0, okay? To help you pass and to do things faster. Because this experiment, you are supposed to do it in less than 35 minutes. This is a practical. So you are supposed to be fast. So if they give you such a table, you will write 1, 2, 3, 4, 5, and then you start. Initial, you put 0, 0, 0, 0, 0. Titration, you put 0.1, 8.1, 8.5, 19, 20. But if you want here, you can even put 19.8. It's up to you, 19.8. As long as it's between here. Okay? If you want, you can put 20. It doesn't matter the numbers you put, guys, in here. Let them range between 18 and 21. If that's why you want your titration to be. It should not go above 21. Okay? Others sometimes will use a titration between 15 to 18. Okay? Then you put the numbers that range between 15 and 18 here. But the best you can choose, but don't go above 21. Okay? So this is how you do that. So here is to tick the best titration. Tick the best titration. So before we tick the best titration, we will solve the questions first. So I'll wrap this so I can write the questions. So using that box now, the questions are following down here. But remember, okay. Question 1. Question 1 from the same question that we are dealing with. Question 1. Question 1. These are now the questions now. Okay? These are questions. These are questions from this box. Okay? Question 1. Question 1 is, what volume of Q was used? What volume of Q was used? Okay? What volume of Q was used? That was question 1. Question 1 was what volume of Q was used. You remember the one I'm just unwrapping here. I wrote what volume of Q was used. It was 25 or 20 cubic centimeters. I'm just unwrapping it here. Okay? It was written 25 or 20 cubic centimeters of Q. Okay? This was the volume of Q used. This one. So you can either put 25 or 20. If I choose 25, then I don't use 20. If I choose 20, I don't use 25. In the exam, they can either give you both, and then they want you can select one of them, or they can give you 25, or they can give you 20. It's up to them. So they're saying, what volume of Q was used? You remember I wrote the steps. I wrote step 1, step 2, step 3, step 4. Is it step 2 or step 3? The one I'm just unwrapping here, there's no space. The one I'm just unwrapping here, it was written 25 cubic centimeters of Q was used. Cubic centimeters of Q. Because once they put centimeter cubed, it means a volume. Okay? It was written 25 cubic centimeters of Q was used. So this is a volume that was used. So it means it is actually 25. So the answer is actually 25 cubic centimeters. I don't change to decimeters because I'm not using it in calculations. When I'm using it in calculations, that's when I change to decimeters. But they just said what volume of Q was used. So that is question A, question 1, question 2. Question 2, based also from this, it's the same thing. Question 2, what do you do with question 2? Question 2, what is the average? What is the average volume of P? What is the average volume of P? You remember I said this is P. So the average volume, it means this one plus this one plus this one plus this one. So it means the average volume it will be 18.1 plus 18.5 plus 19.5. Oh, plus 19, I mean this is 19. Plus 19 plus 20 divided by, if these numbers go up to 5 or 6 or 6, you add all of them and then divide by the number of them that you want. Sometimes you can even end on 4. If you want, you can put 5. It's up to you. But at least put 4 or 5. Even if they ask you others, don't write them. They're not necessary. Just do at least the first 4 or the first 5 are fine. So they are in 1, 2, 3, 4. So divide by 4. So you add this one plus this one plus this one plus that one. So this one plus this one plus this one plus that one. And then the answer you get divide by 4. Okay? So we have 18.1 divided, 18.1 plus 18.5 plus 19 plus 20. It is 75. 75.6. 75.6. 75.6 divided by 4. So 75.6 divided by 4, 75.6 divided by 4. It is 18.9 cubic centimeters. 18.9 cubic centimeters. That is my average volume. So it means if I want to tick the best titration here, since I have the average volume here, you see, I fail to tick the base, whether it's this one or this one or this one. So I'll go to the one that is near. Have you seen this is 18.9? Which of these numbers is closer to 18.9? It's 19. Because after 18.9 you reach 19. So it's the closest. So it means my best iteration here is this one. 19. That's my best iteration. 19. Because here is saying tick the best iteration. But you can't tick it without you finding the average iteration. You first have to add these and then you divide by the number of them. The answer you get, you check which one is closer to which of these numbers is closer to that answer. If the same number is there, then you pick it. If there was 18.9, that's the one you pick. Okay. We go to the next question. Okay, I'll wrap this. This is question 3. That was question 2 we wrote. We're now writing question 3. Question 3, which is the last question. Question 3, what does question 3 say? Q is 0.100 mole per decimeter cubed. You remember? That's what Q was. Okay. Calculate the concentration. Calculate the concentration of P. In moles per decimeter cubed. Okay, present in Q. My titration here was 18.9. Huh? Let's not forget it. It was 18.9. The average one is 18.9. So 18.9 is my average titration. 18.9. I won't forget it, so I'm putting it somewhere. 18.9 cubic centimeters. That was the average titration. 18.9 cubic centimeters. Okay. So here the question is saying calculate the concentration of P. Okay? Which is the concentration of sulfuric acid. Remember I said P is sulfuric acid. Huh? I said this P here is sulfuric acid. So it means if they say calculate the concentration of P, it means they are saying calculate the concentration of sulfuric acid. Because Q is a base. You remember the letter in the box is the acid. This letter here, the acid is always for this box. So if they are saying calculate the concentration of P, it means they are saying calculate the concentration of hydrochloric acid. That's the one that they gave us in the formula. So how do you calculate this? The first thing is you write those equations once I was teaching you. So you write first the weight equation for this. Okay? So we are combining Q and P. So it is sodium hydroxide combined with sulfuric acid. What did it give us? I taught you this. I taught you how to come up with these equations. Okay? Because you remember Q was sodium hydroxide. I taught you how to write the formula for sodium hydroxide. Don't guess. Use the valencies until you write the formula for sodium hydroxide. I taught you. Plus sulfuric acid. What is it going to give us? I taught you how to do this. This one comes here. This one comes out. It will be sodium chloride plus water. This equation I've taught you how to calculate it. Don't say I did not teach you. Remember I explained how to deal with these equations. I said you're going to use that knowledge later. This is where the knowledge is applicable now. This is where you apply. You are combining Q, which is sodium hydroxide, and P, which is hydrochloric acid. When you are combining it to form sodium chloride. And then you balance the equation. Okay? I'll wrap this. We'll balance the equation now. We'll balance the equation. How do you balance it? Okay? Sodium 1, sodium 1. Chlorine 1, chlorine 1. Hydrogen 2, hydrogen. It's already balanced. Okay. The numbers in front of these are called moles. So there's a 1 here. There's an invisible 1 here. Yes, there's no number. It means it's 1. If there's no number, it's assumed it's 1. So we are relating Q and P. Okay? These are the two letters we are relating. P is the acid. Okay? It's the acid. Q is the base. So meaning that we have two slots here for the acid and for the base. Okay? For the acid and the base. So we have that formula. It's written MV over MV is equal to NA over NB. Okay? So A here, B here, B here, NN. So M means concentration. If you want, you can put C. It's up to you. You can put CA. M means concentration. M, it means concentration of the acid. Okay, let me use simple letters. Maybe you remember. You can use M or C, guys. M means concentration. At the same time, I can put CA. It means concentration of acid. MB, it means concentration of base. Volume of acid. VA, volume of acid. VB, volume of base. Okay? MA, let me try to write again. Maybe you may get confused. MA, it means concentration. But I think you have understood. MA means concentration of. MA means concentration of acid. Okay? VA, volume of acid. Volume of acid. Volume of base. Concentration of base. MB, it means concentration of base. Okay. Anyway, I was just trying to help you to understand these letters so that you don't get confused. So, number of moles of acid, number of moles of base. So, we start now. MA, it means concentration of acid. That's the one they have asked us in the question. They said calculate the concentration of acid. So, on the concentration of acid here, I just put MA because we do not know it. Okay? Times what is the volume of the acid? The volume of the acid, guys, I'll wrap this part so that we do with the volume of the acid. These I've already explained. So we're looking for the volume of the acid. Volume of the acid, you remember the acid we got? The volume in the average titration, the volume was 18.9 cubic centimeters. This was the volume we got for the acid in that box. Okay? When we did the average, this was the volume we got. That's the volume for the acid. So we said whenever you're using this one in any formula, you convert to decimeters. So 1 cubic centimeters is equal to 1,000. How many cubic centimeters is equal to 18.9 cubic? So you cross multiply. I taught you how to convert this. I said you have to convert all the time. These ones need to be converted. Divide by 1,000 divided by 1,000. So that will be 0.0819 cubic centimeters. Okay? Cubic centimeters. So this is the volume that you are going to use. So this volume was the average volume when we added in the titration, but you can't use it in centimeter cubed. You convert to decimeter cubed. So there on it will be 0.0189 over MB means concentration of base. What's the concentration of base? This one. This one is a concentration, moles per cubic centimeters. Concentration of base is 0.100. Okay? Times volume of base. Volume of base, we did it. You remember? We said the volume of base from those steps, if you check those things I was teaching you there, it was 25 or 20 cubic centimeters. This was the volume of the base, if you remember. On step 3, this was the volume of the base. But we said we cannot work with these in centimeters. You convert them to decimeters. Then you converted these other ones. Also, these ones also, you also convert them to decimeters. So, that would be what? 1 cubic decimeter is equal to 1,000 cubic centimeters. How many cubic decimeters are equivalent to 20 to 25? You cross multiply, it will become 1000x is equal to 25. You divide by 1000, you divide by 1000, so we have x is equal to 0.025 cubic decimeters. So this is of Q. This is what? This is Q. Okay? This is the base. This volume is the volume of the base. But since it's 25 cubic centimeters, you convert to decimeters. Okay? It is cubic centimeters. So we have to convert it to cubic decimeters. So this is the one that you're going to use here as 0.025 equals. And the number of moles of the acid. Number of moles of the acid. The numbers that are in front of the acid. You see, this is the acid. What number is in front? 1. So I put 1. If there was 2 here, you put 2. Maybe when you are balancing, you find that there's 2 here. You put 2 here. Okay? But here it's 1, so I put 1. But if it's 2, you put 2. If it's 3, you put 3. Next, number of moles of the base. The base is this one. What's the number of moles? The number in front is 1. If it was 2, you put 2. If it was 3, but here it's 1, so even here you put 1. Oh, on top here it's 1, and also down is 1. Okay? Number of moles of the acid. Number of moles of the acid. It means the numbers in front, the ones that you're going to put here and here. Then you cross multiply. So it means MA, this is simple mathematics. Cross multiply, so that will be 0.0189 MA is equal to this one times this one. You multiply this times 1. I think you know how to do this. I'll use shortcut so that you're able to do. I multiply this times 1. I think you know how to do that. If you are doing mathematics, this should be easy for you. This is just mathematics. So you are making MA the subject. Okay? So 0.100 times 0.189. Okay? So 0.10. So 0.10 times 0.025. So that would be 0.025. That would be the answer. Okay? Times that one, I think you already know how to do that. You divide by 0.0189. Also this side by 0.0189. You cancel this, you cancel this. So concentration is going to be equal to this one divided by this one. (0.025) divided by 0.0189. It is 1.3. moles, since this is the concentration of the acid, per decimeter cubed. That's how you solve this. That's all. Please make sure you understand this. You pass through it slowly. You see, the first thing we did, we wrote the weight equation, we balanced it. These numbers in front, the ones that you put here and here. Okay? Number of moles of the acid. You get on the acid, you put here. For the base, you put there. This is the concentration of the acid. So, both the concentration of the acid was this one was the concentration of the acid. We have to convert it to decimeters. Even the concentration of the base, convert to decimeters. That's when you put them in this formula. And then you cross multiply. You make Ma the subject. That's all. And then this is the answer. 1.32 moles per decimeter cubed. Thank you.